बिल्कुल सर. Hello everyone, I am Ashish and welcome to Infinity Learn by Sri Chaitanya. So in this particular live session, I would be taking the most fascinating and most interesting topic of the complete mathematics of 11th and 12th, that is permutation and combination. Why it is more fascinating? Because it is not completely formula driven. It is one of those topics which is logic driven, or which is based upon how do you think, how you comprehend. One of my favorite topic, and yes, it is one of those areas where you can score marks and that defines your rank. So in this particular online session, I would be taking you into the world of PYQs, which is the previous year questions on permutation and combination. And through those problems, we would also try to learn the concept and the application. So stay with me and we will dive into the world of permutation and combination. So before I move forward, right, I would like each one of you to like and subscribe the channel, right? Why do we need to like and subscribe? So that at the end we should get all the updates about all the workshop. Because in the coming days we would be organizing various topics of maths, physics and chemistry apart from few other workshop. So I don't want you to miss any of those workshops. So make sure that you like and subscribe the channel, right? For subscription, you can go to YouTube and search for Infinity Learn JEE, right? That is the name of the YouTube channel for us. So now I'll move on to the first question. Now if you read the first question, says number of 6-letter words with or without meaning formed using all the letters of the word called as vowels, so that all the consonants never come together. Now the question over here says that I have to arrange all the alphabets of the word vowels, right? Because there are 6 alphabets and I have to arrange all these 6 alphabets. But there is a constraint. Let us look at the constraint. The constraint says all the consonants never come together, which means that I have to find out all those arrangements where the consonants are not together. Now in such kind of question, how do we move ahead? Right. Now we'll find out the total number of arrangements. Total number of arrangements will include when all the consonants are together, or when few of them are together, some of them are together, and those cases where the consonants are not together. So to find out the answer over here, can I use the approach as answer would be total number of ways or total number of arrangements, right? So first we will find out the total number of arrangements and I will subtract those arrangements when the consonants came together. So all those ways where consonants came together, right? So if consonants came together, that means all of them should be joined together. Let us find out how many vowels and consonants we have. The word is, count this entity as 1. So I have 2 vowels and 1 this entity. So how many we have? 3. So we'll arrange these 3 things in factorial 3 ways. Now is this the correct answer? No, right? Why? Because the question says consonants came together. Now I have coupled them by a rope. So now V, W, L, S or 4 will be together. But they can be in any order, right? It can be V, W, L, S or V, L, W, S. So any of the order is possible over here. So over here I have to multiply the number of arrangement inside this particular group, that is among the 4 consonants. So 4 consonants can be arranged in 4 factorial ways. So my total value would be factorial 6, that is 720 minus factorial 3 is 6 into 24. So your answer is 720 minus this is 144, right? So if I subtract this becomes 576. So 576 would be the correct answer for this particular example. I hope the concept is clear, right? Because the only mistake in PNC that most of the students do is they try to memorize all the formulas and they try to apply formulas everywhere. Do not memorize all the formulas. Just understand or comprehend the problem. Think about what are the possible cases over there and then make the cases and do the counting. I normally say if you follow the principle of counting, that is the method of multiplication and addition, right, you can answer 90% of the problem that is being asked in the previous year JEE problems. You don't have to memorize the formula. Let us move on to the second example now. The second example says it appeared in the 2021 paper. So a number is called as a palindrome if it reads the same backwards as well as the forward. For example, 28582. Now if we start from the beginning, it is 285 and 582. If you start from the end, 285 582. So if you read forward or backward, the number is still the same. These kind of numbers or words will be known as palindromes. Now over here I have to find out the number of 6-digit palindromes which are divisible by 55. Now in this particular question, right, I have to use two different concepts. First, the divisibility test. Now divisibility test of 55, it's a composite number, right, and for composite numbers I have to check the divisibility test of their prime factors. So first of all, let us observe this 55. What is 55? 55 is nothing but 5 into 11. So if a number is divisible by 55, can I say the number is divisible by 5 and the 11? Yes. So any number that is divisible by 5 and 11 will be divisible by 55. What is the divisibility test of 5? Divisibility test of 5 says the last place needs to be either 0 or 5. What is the divisibility test of 11? Right? It's the sum of the alternate digits. Right? If I take the sum of the numbers at even places and the odd places, the difference of these two should be a multiple of 11. So now let us observe any palindrome. Let's say a palindrome would be ABC and CBA. This is how the 6-digit palindrome will look like. Now I will apply the divisibility test of 11 first. So you will take the sum of odd places. So A plus C plus B. Now you will take the sum of the digits at the even places. That would be A plus B plus C. See, it is B plus C plus A. I can also write it as A plus B plus C. Now if I take the difference of these two, it will always be 0. And 0 is a multiple of 11. So I can say no matter what numbers you take, a 6-digit palindrome will always be a multiple of 11. So in this particular example, I don't have to check the divisibility test for 11. But yes, we have to check for 5. Now if I have to check for 5, this number should either be a 0 or a 5. But if I put a 0, then over here at the first place, I will also have a 0. At the first place, we cannot place 0. Otherwise, it will become a 5-digit number. So I know the only possibility here would be that A should be filled by 0. So we have solved till this particular place. There are 6 places. The first place would be 5 and the last place would also be 5. And we are left with B, C, C, B. So now I have to fill only these 4 places. B and C can be any numbers, right? Now this 6-digit palindrome will always be a multiple of 5 and 11. So I just have to count how many different ways I can have to fill these 2 places. Now see over here, if I take the B, this place will always be fulfilled in one way because I don't have to fulfill. If I have picked B, that number will repeat over there. If I have picked C, this number will be repeated over here. So I don't have to fill these 2 places. So this can be filled in one way, this can be filled in one way, this can be filled in one way. So I have to select B. Now for B, how many options do I have? I can select any number from 0 to 9. So for B, I have 10 ways available in which I can fix or choose a value for B. Similarly for C, once again, I have 10 ways. Because both B and C either can be same or they can be different, right? A palindrome, for example, let's say if I write 6666, this is also a palindrome, right? Because if you read forward or backward, the number will read as same. So over here, if you observe A, B, C, all are same. So in palindrome, it is not necessary these two should be distinct. They can be same. Hence, over here, I have to take there are 10 ways in which I can select the C. So there is an AND condition. I will multiply all of them. So if you multiply all of them, your final answer would be 100. And that would be answer for this particular problem. Now you can observe from this particular example, I have used no formula anywhere. What I have used is the simple logic that we have studied in class 9th or 10th or 11th and 12th, right? But it's simple logic. There is no formula. There is no approach. I am just comprehending the example and following the number of ways. That is what I would suggest to each one of you. Read the problem, think what are the different cases which are possible, and apply the logic, you will always get your answers, and answers as the correct answers. Let us take the other example. This is one of my favorite example. In each of my class, I always discuss this particular example right at the beginning of the lecture. Right. The question says, how many times you will write digit 3 when you write all the numbers from 1 to 1000, right? Now, there are different approaches in which you can comprehend this particular example, and that's the beauty of this particular question, right? So, इस question में, let's say I talk about the approach 1. Now, the moment you hear about this particular question that I have to count the number of ways 3 appeared when I write all the natural numbers from 1 to 1000, the very first thought that comes to your mind is, okay, so I have to count 3. So there will be single digit numbers, double digit numbers and triple digit number. That thought that came into your mind is basically my approach over here. So now I will make 3 cases, case 1, case 2 and case 3. What is case 1 over here? Case 1 is, I will count the number of 3 used when I am writing a single digit number. Case 2 when I am writing a double digit number. Case 3 when I am writing a triple digit number. So in a single digit number, a 3 will be written over here. It can be done in only one way. So I have 3 over here. Now case 2 when I am writing a 2 digit number. Now in this particular case, 3 can appear at 2 places, either at the unit place or at the tens place. So I have to form 2 cases in the case 2. Either 3 is appearing over here or 3 is appearing over here. So if 3 is appearing at this place, it can be done in only one way. Write 3 at the unit place, tens place. And at this place, unit place, I can write any number, any digit from 0 to 9. So hence I can say this can be filled in 10 ways, right guys? And condition, multiply you both of them, you get 10, right? So there are 10 such numbers in which 3 is being written at the first place. Over here, this place can be filled in one way. Now at the first place, can I write 0 over there? You guys are smart, right? I cannot write 0 over here. So there are 9 ways available for the first place because I can write only 1 to 9. 0 is not available. Because if I write 0 at the first place, it will become a 2-digit number. No, it becomes a 1-digit number. Now, I am counting case 3, 3-digit numbers. So we'll have 3 different possibilities over here. So either I can have a 3 over here, or I can have a 3 over here, or I can have a 3 over here, right? Now, if I have a 3 over here, this can be filled in one way, right? Now, this place can be filled in how many ways? 10 ways. I can use any number. I can also write 0 in between. This place, once again, 10 ways. If I multiply, I get 100 such numbers. Now, if I have a 3 over here, the first place cannot be filled by a 0. So, I have to fill 9 ways. Over here 10 ways. This is 1. This becomes 90. Once again, first place 9 ways, right? 0 cannot be written over there. So 9 into 10 into 1. Now if I add all of them, right, I will get the number of times 3 is being used. Let us add all of them. 90, 90, 180, 280, 290, 290 and 10 is basically 300. So 300 times I have written 3 over here, right? Now why this is an interesting problem? Because it depends on how you approach this particular example. Let's say if you approach in a different way altogether. Let's say when you read the problem, right, you have to count the number of 3's. So the thing that comes to my mind is, okay, fine. So I can see 3 at 3, 13, 23, 33, 43, 53 and so on. So I know if I take 1 to 100, if I take all the natural numbers from 1 to 100, how many times I have written 3? 3, 13, 23. So at unit place, you will write 3 10 times. Right? This is for the unit place. Similarly, for the tens place, I have written 30, 31, 32 till 39. So 10 such numbers are over there. So I have written 10 times 3 at the tens places. So in total, I have written 20 times. So if I take any 100 natural numbers, right, from 1 to 100, or let's say any 100 continuous natural numbers, I will always write 3 20 times at unit place and the tens place. Right? सोच के देखो, if I take all the natural numbers from 1 to 100 20 times, if I take 100 to 200 20 times, right? 200 to 300 20 times, 300 to 400. Now I have 3 at the 100 place, so I have to count those as well. So first I will complete this. So in every 100 consecutive natural numbers, 20 times you have written 3 at the unit place and the tens place. So how many packets do I have? I have to write down from 1 to 1000. So if you observe 100k, I have 10 packets over here. So 20 into 10. So that makes 200 times. Are you getting my point? 200 times I have used 3 at the unit place and the tens place. Now at the 100 place, where do I use 3 at the 100 place? When I write the natural numbers from 300 to 399. How many times I have written 3 at the 100 place? 100 times. So 100 is being written at the 100 place. So the sum of these two will be 300. That is exactly same as the answer below. Now this particular example can be solved in more than 4 different approaches, right? But we have a time constraint over here, so I will discuss only 2 of them. We'll discuss more afterwards. Rishabh, you have a doubt that 33 will be repeated. Yes, dude. Dekho, that's a nice question. Now over here, 33 would be repeated. Similarly, over here, if you see 334, या फिर 333 will be repeated. But over here, I am counting the number of times I have used 3. Now, for example, let's say 33. So, how many times you have to count 33? Twice, right? Because you have used 3 2 times. So, when 33 is there, you have to count it twice. Now, observe over here. 33 is being counted over here. Yes. 33 is being counted over here. Yes. So, 33 is being counted twice, and I have to count 33 twice as well. Hence, your answer would be correct. Similarly, 333 has been counted thrice over here. Right, Rishabh? If you have got the logic, you can say yes or thumbs up. That will do. Right, guys? So, 333 over here should be counted 3 times. And if you observe, right, 333 has been counted 3 times over here. So, we move on to the next example now. What is the next example? Now, it says total number of numbers lying between 100 to 1000. Now, the moment I read 100 to 1000, it clicks my mind, okay, it's going to be a 3-digit number only. That can be formed with the digits 1, 2, 3, 4, 5. Repetition is not allowed. Numbers are divisible by either 3 or 5. Right? So, I have to find out basically how many 3-digit numbers are there, right, between 100 and 1000. So, it will be always 3-digit numbers which are divisible by either 3 or 5. Right? So, let's say we can count it by the number system only. The smallest number would be 100. Then I have 101, I have 102 and so on. The last number would be 999. Right? So, these are the numbers. Now, in these numbers, I have to count down the number of or the numbers which are divisible by 3 or 5. So, let us find out divisible by 3. How many numbers are divisible by 3? Now, the smallest number divisible by 3 would be 102. Right? Now, if you divide 102 by 3, what do you get? Divided by 3, right? It would be 34. Right? I think it is 34. Right? So, this is 3 into 34. And the last number divisible by 3 is what? So, like I can write over here 3 into 34. The next number would be 3 into 35 and so on. What is the last number? Last number is this 3 into 333. Right? So, now if you observe the multiples of 3 starts from 34 go till 333. So, how many numbers do I have over here? 333 minus 34. That makes 299 plus 1. So, that makes 300. Right? So, I have 300 multiples of 3 when I see all the numbers from 100 to 999. Let us see how many multiples of 5 do we have. 5. The smallest would be 100. That is 5 into 20. And what is the largest? That would be 995. So, 5 into 199. Right? So, from 20 to 199. So, how many multiples of 5 do I have? Subtract 199 from 20. That makes 179. but I have to count both these numbers, right? Whenever we take the difference, one of the end will not be counted. So if you have to count both the ends, we have to add 1, right? So over here I have 180 multiples. Now I have 3 multiples, 300, multiple of 5, 180. So can I say my answer would be 480? No, right? Because there are few multiples which are being counted in 3 as well as in 5. For example, let's say a multiple of 15. Any number which is a multiple of 15 is being counted over here and is also being counted over here. So the same number is being counted twice. So I have to subtract, or I have to find out those numbers first and then have to subtract. So multiples of 15. So I will simply find multiples of 15. What is the first multiple of 15? That is 15 into 7. That is 105. What is the last multiple of 15? Right? So let's say if I don't know what is the last multiple of 15, no worries, divide it by 15. So 999 divided by 15. Right? So let's say in exam, right, मेरा दिमाग नहीं चल रहा है, मेरे को नहीं मालूम 15 का कौन सा multiple आएगा, divided. So it would be 15, 6 90. So I have a 9 carry forward. 15, 6 90. I have a 9 remainder. So it would be 66 point something. So I can write this will go till 56, 15 into 66. 67 will go beyond 999. So now how many multiples of 15 do we have? From 7 to 66. So if I subtract, I get 60 over here. So 60 numbers are being repeated in 3 and 5. So what is my answer? My answer would be multiple of 3 plus multiple of 5 and subtract the multiple of 15. That would be 420. Right? 420 या फिर 420. तो अपना आंसर कितना हो गया? 420. And if you have observed, I have used a Venn diagram logic, that is NA plus NB minus N of A intersection B. So logically we have used this only, multiple of 3 plus multiple of 5 minus multiple of 3 and 5, which is multiple of 15. Right? So let's see the other example. Now see, in these examples you are also observing that we are not using any formulas over here. It's purely logic. So stick to your logic and you can solve each and every problem of PNC. So now I have to find out number of 6-digit numbers in which only and all the 5 digits appear. Okay, so I have 5 digits and the question says you have to form a 6-digit numbers. I have to use all the 5 digits. So in short, one of them would repeat. That is for sure, right? So let's say one of them would repeat. So I have 5 digits already. Now one of them would repeat. Now which one would repeat? 1, 3, 5, 7, 9. So I will select one out of these, right? Why I am selecting one? The number which I have to repeat. So 5C1, now I got which one number to repeat. Let's say in 5C1 you got 7. So now I have 1, 3, 5, 7, 7, 9. Now I have these 6 digits and I have to form a 6-digit numbers. So I have to just arrange all of them. So 6 digits I have to arrange, but 2 7s are identical, right? So in the arrangement, whenever things are identical, how do we proceed? We consider them to be distinct and we calculate the answer. And at the end, we'll divide the final answer by the factorial of the number of identical things that we have arranged. So now I am considering these 2 7 as distinct. So I have 6 distinct things. I can arrange them in factorial 6 ways, but 2 7s are identical. So I will divide my answer by 2 factorial, by the factorial of identical things. Now this will be your answer. 5 into 720 by 2. So this becomes 5 into 360. Now what is 5 into 360? I hope it is 1080. Sorry, it is not 1080. This is 1500 and this is 1800. Right? So the final answer would be 1800. Right guys? Let's move on to the next example now. So the next example, it says number of ways in which 5 boys and 3 girls. So now we have some humans, right? So far we were playing only with the number system problems, right? So 5 boys and 3 girls, we have to arrange them at a round table. So a circular arrangement, particular boy B1 and a G1 never sit adjacent to each other. Okay, so B1 and G1 says, we don't want to sit together, right? No matter how you arrange everybody else, we want to be at different places or apart. So now how to arrange these, because I have to sort out this constraint between B1 and G1. So what I'll do is, over here I will also use the same approach that we did in the example number 1. Remember, I will find the total number of arrangements. Now total number of arrangement will consider all the possible cases when B1 and G1 are together, when B1 and G1 are separated. And if I subtract those cases when B1 and G1 are together, I will get the cases when B1 and G1 are not together. So I'll use this particular approach. So my answer would be total arrangement minus when B1 and G1 are together. So I'm tying them by a rope, right? Whenever you need to keep things together, you have to tie them by a rope and count them as 1. So total number of arrangement. But over here, remember, it's a round table, right? Now round table arrangement or a circular table arrangement, if there are n things to be arranged, the total number of arrangement is given by n minus 1 factorial. If anti-clockwise and clockwise are distinct, if they are same, you will divide your answer by 2. So now over here, first I have to arrange 5 boys and 3 girls. So in total I have 8 students to arrange. Now 8 students can be arranged on a circular table in factorial 7 ways. Now minus those cases when B1 and G1 are together. So you tie them by a rope. So now if you tie them by a rope, you have B1 and G1, and then you have the remaining 6 people, B2, B3, B4, sorry, B5, 5 boys were there and 3 girls were there. So you have 6 these people and 1 this packet. So I have 7 people, right, or 7 things. 7 things on a circular table. So that would be factorial 6. Don't forget, right, you have 7 things you have to arrange on a circular table. And then B1, G1 are tied by a rope. So inside the rope also I can do the arrangement. So B1, G1 or G1, B1. See, over here sometimes students do this factorial 6, and over here they also say, sir, I am doing a circular arrangement. So over here also it is 2 minus 1. Always remember, the n minus 1 factorial for the circular arrangement, it has to be done only once. If it is done once, then your experiment or that particular question becomes similar to a linear arrangement. Now you have to use factorial n always. So over here my answer would be factorial 7. I can write this is 7 factorial 6 minus this is nothing but 2 factorial 6. So my answer becomes 5 factorial 6. Do I see 5 factorial 6? Yes, option number 1 is 5 factorial 6, and that would be your correct answer for this particular example. Right, so I hope you guys are enjoying so far, right? So we'll continue with this particular session and we'll have some more examples and some more concepts on PNC. Now the next example, 8-digit numbers are formed. Now you are also observing, right? In the PYQ, there are more problems on the number system, and whenever a problem of the number system is there, that means I have to use the basics. So now 8-digit numbers we have to form, and now what is given? Okay, so now they have repeated the numbers. So there are 2 1s, there are 3 2s, 1 3 and 2 4s. Okay, fine. So the number of such numbers in which the odd digits do not occupy the odd places. Right. Now what does the statement say? Odd digits do not occupy the odd places. What are the odd digits over here? Now odd is 1 1 3. These are the odd. And I have to form a 8-digit number. So 1 2 3 4 5 6 7 8. Right? So out of these 8 digits, let me number them. 1, 2, 3, 4. So I am numbering them, right? So odd places are 1, 3, 5, 7. Right? So I have to make sure that the odd digits, which is 1, 1, 3, does not comes at these 4 places. Right? Now, one simple advice that each one of us know. Whenever you see a constraint or a condition or a restriction, always do the restriction first and then do the rest. Right? It's a simple concept. Most of the cases as a student, right, we tend to do the other cases first and then the restriction. You will always find that your answer is incorrect. Always fulfill the restrictions first. So over here, I will fulfill the restrictions first. What are the restrictions? Odd digits should not come at the odd places. Right? So now I have 3 odd digits. So they need to be placed at the even places. How many even places I have? 1, 2, 3, 4. But I have 3 digits. So I will select 4C3, the 3 places where I would keep my odd digits. The 3 odd digits can be arranged at those 3 places factorial 3 ways, but 2 ones are identical. This is my answer, right? Well, this is incomplete, I have to complete it. So now what I have done is, I have selected the 3 places out of the 4 even places and I have arranged the 3 odd digits at the even places. Now all my odd digits are at the even places, I don't have to worry about them now. Now the remaining 5, I can arrange them anywhere. So now how many are left? We are left with 5 digits. These 3 and these 2. And how many places do I have? 5. So I have to arrange these 5 digits at the 5 places which are left. So I can arrange them in 5 factorial ways, but the 2's are identical, so I'll divide by factorial 3 because there are 3 2's and 2 4's are also there. So divide by factorial 2. Let us simplify this. Now what is 4C3? 4C3 is basically 4C1, and what is 4C1? It is 4. This is 4 into this gets out, I have factorial 5. Factorial 2 is also 4. So my answer is factorial 5 or 120. Do I see 120? Yes, very well. Option number 2 is my correct answer. Right? Now the next question. Now this is also an interesting question. See, assuming the balls to be identical except for the difference in colors. Now what does this statement means? The balls will be identical except for the color. So if I have a red color ball and a green color ball, I will call them as distinct balls. But if I have 2 green color balls, I would say they are identical. I cannot distinguish between them. So this is what the question means. I have to find the number of ways in which one or more balls can be selected from this. Right? Now it's a very interesting problem because I have to select. But look over here. The number is not given. How many do I have to select? Then how to proceed? Because if I think logically over here, I can select 1 white ball, 2 white ball, 3, 4, 5, any number of possibilities are there, right? That thought comes to our mind. As I mentioned before as well, whatever thought comes to your mind when you read a problem is basically the approach. So over here, that is my approach which we have just thought. Now see, when there are identical things, right? Let's say for example, if I have 5 apples and if I have to pick any number of apples, now my number of selection, I cannot apply NCR because NCR is only defined for distinct things. When there are identical things, in identical things, the quantity defines the number of ways. For example, if there are 5 apples, so I can pick either 1 or 2 or 3 or 4 or 5 or none. So there are 6 different ways available, that's it. I cannot select the 2 apples, okay, these 2 or these 2 because they are identical. You don't have to select, we just have to select the quantity. Right? For example, let's say if you go to a grocery shop and you want to buy an eclairs, right? If you want to buy 3 eclairs, you have to just pick 3. You don't select this one, that one or that one because they are identical, they are same. Same is the logic over here. So if I have to pick from 10 white balls, see, now we have comprehended the question. So now it is just that we will get the answer in one step. Now 10 white balls. So how many ways are there? I can select 1 white ball, 2, 3, 4, 5, 6, 7, 8, 9, 10 or 0. So there are 11 ways available. Okay. 9 green balls, how many ways are available? 10. 7 black balls, how many ways are available? 8. And condition, right? Because I have to pick from here and here and here. Whenever there is an and condition, I should multiply. Now, is this my answer? Over here it says 1 or more than 1 ball. That means in minimum you have to select 1 ball. Now see over here, I have taken 11 cases. Out of those 11 cases, 1 case is where I am not selecting any white ball. But if I don't select any white ball and if I select 2 green balls, then at least I have 2 green balls at the end. So this condition is fulfilled. But what if out of these 11, I have select no white ball, no green ball, no black ball? That case is also being considered over here. And in that particular case, my hands would be empty, right? I will have nothing. So I don't have to count that case. And in how many ways I can select none from it? 1, right? There is one way in which I can select 0 balls. That you go there, select nothing. So I have to subtract 1 from it. So my answer becomes 880 minus 1. Don't forget this minus 1. Because if you check the option, you will also find 880 among there, which is option number 1. But the correct answer is 879. That is option number 4. Right? So let us move on to the next example now. Wonderful. It's a very pretty old example, came in 2004, but it's an interesting example, that's why I have picked it. And in many of the questions you have also seen in JEE, right, last 2-3 years paper, that questions are being repeated. So it's an interesting problem. It says 7 minus xp, this is NPR. So 7 minus xp, x minus 3. Right? Now, when we talk about NPR or the number of arrangements, the things will always be natural numbers, right? You cannot have root 3 toffees or 1.7 boys. You will always have 3 or 4, right? So 7 minus x, this needs to be a natural number for sure. X minus 3 needs to be a whole number, because I can also arrange 0 things out of available 5 things or 4 things. So that's why it is a whole number. And at the end, 7 minus x needs to be larger than x minus 3, because if I have 10 things, I cannot arrange 11 things. Out of 10 available things, I can arrange either 7, 8, 9, 6, 5 and so on. So I know 7 minus x needs to be larger than x minus 3, or can also be equal to. I can also arrange all of them, right? So from here, I'll simplify. 3 comes over here, it becomes 10 is larger than equal to 2x. So can I rewrite this as 2x is less than equal to 10? Divide by 2. In an equation, I can divide by a positive number. So x is less than equal to 5. Now over here, 7 minus x needs to be a natural number. So x, 7 minus x. So x cannot be larger than 7. If it's larger than 7, 7 minus x becomes negative, right? So x is less than 5. So x is less than 5, 7 minus x will always be positive. Now over here, x minus 3. X cannot be less than 3, because if it is less than 3, it becomes negative. So I know x needs to be larger than or equal to 3. So from here, I get the values of x is equal to 3, 4, 5. Right? Now, why I have said this is an interesting example, because in the exam, while solving this, students think 3, 4, 5 is the answer and they look for the x values. Right? Because this is our habit is, we always find x. So my x is done, it should be there in the answer. But remember the question was not x. The question was find the range of the function. Now what is the range of this function? Range would be the value of y. So f3, f4 and f5 would be my range. So what is f3? Put x is equal to 3. So 4p0. Put 4. There is 3p1. Put 5. There is 2p2. Right. What is 4p0? That is factorial 4 upon factorial 4. There is 1. This is factorial 3 upon factorial 2. This is 3. This is factorial 2 upon factorial 0. And that is 2. So 1, 2, 3, which is your option number 4, which is the range of this particular function that is given by. Now, if the question would have been the domain of the function, then the answer would have been 3, 4 and 5. Right? So always remember, you might can come across NPR or there might can be NCR. NCR, once again, things would be same. This would be natural, this would be whole number, and this has to be larger than or equal to the x minus 3. So the next problem comes from the geometry, came in 2021, that is the last year. Right, so sides of the triangle AB, BC, CE are given. 3, 4, 5, 3, 5, 6 are the interior points. Wonderful. So what do we need to find out? Number of triangles. Right, so to form any triangle, we just need 3 points, right? Because 3 non-collinear points gives you a triangle. Why I am focusing more on non-collinear? Because if there are 3 collinear points lying on the line, then I will have a line. I don't have a triangle. For a triangle, I should have 1, 2 and 3. So 3 non-collinear points should be there. So I have to find out the number of triangles using these points at the vertices. Now be careful when you read a problem and comprehend. The question says these points at the vertices. Which point? The interior points. I don't have to count A, B and C. Right? If ABC needs to be counted, it would have been specified over here. So that is a trap over here, because in most of the books that you might have solved, A, B and C are always included. Now over here, the question says these points, which is 3, 5, 6. So on AB, I have 3 points. These are the 3 points. Let's say I call them as A1, A2, A3. Then I have 5 points over here, 1, 2, 3, 4, 5. Let's say I call them B1, B2, and so on till B5. And over here I have 6 points, 3, 4, 5, 6, C1, C2 till C6. So I have to make a triangle using these interior points, not ABC. So for these 3, let's say this is a triangle formed, alright. This is a triangle formed, right? Now if I take 2 points on a side and 1 point on any of these sides, I can make a triangle. If I take 1 over here, 1 over here, 1 over there, I can still make a triangle. But if I take 3 points on one side, I won't get a triangle, right? So my answer would be, for a triangle, I just need 3 points. How many total points do I have? Count all of them. 5 plus 3, 8, 8 plus 6, 14. So I have 14 points, 14C3. Number of ways of selecting 3 points, because every selection of 3 points will give me one triangle. So the total number of ways in which I can select 3 points will be equal to total number of triangles. But I have to subtract. What cases? Let's say in 14C3, I have counted all of them. So there might be a case where I have selected only the 3 A's, or I have selected 3 points from the B. Then I get a straight line, not a triangle. So I have to subtract those cases. First, I will subtract those cases when I have got 3 points from A. So 3C3. Those cases when I have got 3 points from the point B. 5C3. Those cases when I have got 3 points from the C. Right? So this would be my final answer, that is 14C3 minus 3C3 minus 5C3 minus 6C3. Let us simplify this. So 14C3 would be, now see, whenever you have to calculate the NCR, I give you a trick. Write 14, the tail is 3. So write 3 consecutive natural numbers, 14, 13, 12. That's it. And divide by 3 factorial. 3C3 is 1. 5C3 is 5, 4, 3 divided by 6. 6C3 would be, I will write 3 consecutive natural numbers because I have a 3 at the tail, and divide by 6. So this gets out, 3 2s are 6. This gets out, now 6 2s are 12. This gets out. So now I have 28 into 13 minus 1 minus, I have a 10 over here and I have a 20 over there. Right. So we can simplify this and we can find out the answer. Or let us simplify this. What is 28 into 13? That is a multiply, right? So I have 3 to the 60 and 24. So this is 84. This is 28. So I have 4, 16, 364. So this is 364 minus, this is 31. So I got 3, 3, 3. Oh, that's a nice number, 333. Where do I see 333? Option number 4 is the correct answer. I hope this question and the logic is clear to you, right? So always comprehend the problem correctly. Read it correctly, right? If you have misread the problem, then obviously your answer would be incorrect. So don't panic inside the exam. Just be calm and composed. You have prepared for almost like 2 years, right? And in the COVID time, you have prepared more than 2 years. So believe on you, believe on your strength that you have studied. So you will be able to sort out and solve the problem. So don't panic inside the examination hall. Now, see, an interesting problem. Why it is interesting? Because once again, it involves the counting and the interpretation. A scientific committee is to be formed from 6 Indians and 8 foreigners. So I have 6 Indians and 8 foreigners, which includes at least 2 Indians and double the number of the foreigners as Indian. Understand the statement carefully. I have to form a committee which includes at least 2 Indians. So minimum 2 Indians has to be there. And double the number of foreigners as Indians. So the number of foreigners will depend upon the number of Indians that you take, right? So I got my logic that I have to fix the number of Indian first. Once I fix the Indian, then only I can get the number of foreigners. If I get the number of Indians, number of foreigners, then it's just a game of selecting from 6 and 8. Is there anything else? No. Right? So number of committee members is not given. So I have to form the cases first, Indian and foreigner. So the first case, I can have 6 Indians, right? So minimum is how much? 2. So 2 Indians, then I'll have 4 foreigners. When I have 3 Indians, I will have 6 foreigners. When I have 4 Indians, I will have 8 foreigners. When I have 5 Indians, no. I cannot have 10 foreigners. Why? Because I have only 8 foreigners. So these are the 3 possibilities. Right? So let us calculate for each possibility. I have to select 2 Indians. How many Indians do I have? 6. Select 2. 62. How many foreigners do I have? 8. How many we need? 4. It's an AND condition, right? Because I need 2 Indians and the 4 foreigners to make a committee. Second case. Now quickly calculate this. 63 into 8C6. What is this? 64 into 8C8. Right? Now I will simplify these values. Remember the trick that I told you, Abhi? 62 would be what? 2 numbers divided by factorial 2. 8C4 would be what? 4 numbers decreasing order divided by 4 factorial. That is 24. So I'll simplify 8 3s are 24. 2 gets out with 2. So I have 7 6 are 42 into 25. Okay. Now this is 63. So 6 into 5 into 4. Right? Upon 6. 8C6 is nothing but 8C2. So I can apply 8C2 over here. This is 2. So this is 8 7s are 56 into 10, 560. 64 is 62. 8C8 is 1. This is 15. So your answer is what? You got 42 into 25 plus 560 plus 15. Now what is 42 into 25? 425 makes 100, right? So 40 will make 425, right? 4 into 25 makes 100. So a pair of 425 makes 100. How many pairs do I have? 10. So I have 1000. 1000 plus 2. So that is 1050 plus 560 plus 15. So this becomes 1500, 1600, 1625. Right? So we have option number 1 as 1625. Alright guys, let us move on to the next example now. The next example, as you can see, appeared in the online exam in 2018 and reappeared in 2020. Right? Now, some of you might can doubt that why there is an online exam. Previous to COVID, right, in mains, there were 2 papers. Either a child can select an offline paper or a child can go for the online paper. There were 2 options available for a child to attempt the JEE Main. So now, I have to find out the number of 4-letter words that can be formed from the 11 letters of the word examination, right? So now, I have to make a 4-letter word. Examination, the alphabets also are also repeating, right? So now the thought comes to my mind, okay, if I form a 4-letter word, there can be different possibilities. One possibility where all the 4 letters are distinct. Another possibility, some of them are distinct, some of them are identical and so on. So that will define my cases over here. So let us form the cases. So now that is what categorize all the alphabets, right? So I have E. How many times I have E? Only 1, right? X, 1. A, I can see 2 A's. M, 1, right? Sorry, this is 1. So M is 1. What is I? I is 2. N is again 2. A already has been taken care. T is 1 and O is 1. Right? Always make a habit of counting all the numbers so that we make sure we have not missed anything. Now 2, 4, 6, 8, 10, 11. And there are 11 letters. So I know I have not missed anything right now. So now from here I can make the cases. Now the cases would be what? Either I can have all the 4 letters distinct. I cannot have 3 same because there are no letters which are 3. I can have only at max 2 same. So 2 same and the remaining 2 are distinct. I can have the 2 pairs of same, right? There is no other possibility apart from these. So So this is case 1, case 2 and case 3. If I would have a 3 over here, then I could have said 3 letters same and 1 distinct. If I have some alphabet which are repeated 4 times, I could have said A would be one of my possibility. But over here, these are the 3 possible cases. Now for this, I have to select 4 letters, right? Now 4 distinct. How many distinct do I have? Count over here. How many distinct? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 distinct alphabets. So I can select 8C4. So I got all the 4 letters. Now arrange them to get the 4 letter words, because at the end I need to find the 4 letter words, meaningful or not meaningful. Now I have to select 2 which are same. Now the same can be selected from this, this or this. So which of these 3 will I repeat? So I'll select 3C1. Right? For example, let's say 2 A's. So I have A now. I have to select 2 distinct. Now I cannot select the A. 1, 2, 3, 4, 5, 6, 7. I can still select one I, right? So from 7 I need to select 2 which are B and C. Right? So now I have 2 same and 2 distinct alphabets. I'll arrange them 4 factorial and I will divide them by 2 factorial. Right? Because those 2 alphabets are same. So if I have to arrange them, I have to divide them by factorial 2. Now I have to select 2 pairs of 2, 2. So 2 pairs of 2, 2, I have this possibility or this. Rest others I cannot select. So out of these 3, I have to select any 2. Right? So let's say if I select A and I, so I will have AA, II, 4 letters which needs to be arranged. Now these 4 letters can be arranged in 4 factorial divided by 2 factorial, 2 factorial. Right? So we can calculate this to find out the answer. So this would be 8C4 into 4 factorial. So this would be 8 into 7 into 6 into 5 upon 4 factorial into 4 factorial. Now over here 3C1 is 3, 7C2 is 7 into 6 by 2, factorial 4 is 24 by 2, and 3C2 is 3, 4 factorial upon 4. We can calculate these values and the sum would be final answer. So in this example, I am not doing the calculation part. You can easily do the calculation part. The logic is pretty clear, right? How do we calculate the number of 4 letter words when such kind of words are given? Always remember, classify them first, then make all the possibilities. Once the possibilities or the cases are being listed, then it's an easy peasy task. You just have to select and arrange according to number of identical things which are over there. Right, guys? So let us move on to the next question. Next question says 20 pillars of the same height have been erected along the boundary of a circular stadium. Like the moment I start reading this particular question, I feel as if this question is something new. This question would be difficult, right? That is my preconceived notion. But if you understand, right, inside the examination hall, always make sure that you read it completely. Don't go by a preconceived notion that, okay, fine, this looks like difficult or this looks like easy. Now this problem, to majority of the student, right, I remember when I was talking with the student after the exam, majority of them were like, so that looks difficult. But when we solved it, it was an easy one. It's a very easy question. I would rate it as 1 star if you ask me about the difficulty. So let's understand. 20 pillars of the same height has been erected along the boundary of a circular stadium. Okay, fine. So I have a stadium and there are these 20 pillars of the same height. Okay, right. Now the question says if the top of the each pillar has been connected by the beams with top of the other non-adjacent. So let's say this is a pillar 1. I cannot connect pillar 1 to pillar 2 or pillar 3. I have to connect like this. देखो आ रहा है ना समझ में? Adjacent वाले को नहीं करना. So P1 will not be connected to P2 and P3. With the rest everything I will connect. Now comprehend, if I connect it to the adjacent, right, this becomes the chord, or sorry, this becomes the side of the polygon. What is the polygon? If I join all the points P1 to P20, if I join all these points, let's say I join them, you see, if I join them, I get a polygon. right? So now what do I have to count? I have to count the diagonals of this polygon, and I don't have to count the sides of the polygon, right? And such kind of examples, right, you might have seen in each of your workbook, where in a given polygon we have to count the number of diagonals, right? Now for the number of diagonals, let's say if I pick any 2 points, if I join them, I get a line segment. So how many points do I have? I have 20 pillars. So if I do 20C2, what is 20C2? 20C2 is number of ways in which I can select 2 points. If I select 2 points, I can always draw them and I will have a line. So 20C2 lines would be there. Now these 20C2 lines will include the side and the diagonal. I don't have to consider the sides. So I will subtract the number of sides. So if I have a 20 vertex, how many sides will I have? 20. So I will subtract 20 from this. What is 20C2? 20 into 19 by 2 minus 20. So 190 minus 20. My answer would be 170, which is your option number A, right? Number of diagonals of any polygon will be equal to NC2 minus number of sides, which is n. So NC2 minus n, you can also use it directly. Otherwise, you can always say from 2 points, I will get a line segment. So in total number of ways in which I can select 2 points is equal to total number of line segments. So NC2 minus the number of sides. So the next question is exactly based on the same concept. Now you have Tn is the number of all possible triangles from a n-sided polygon. So now I have a polygon. I don't have to count the diagonals, but I have to count the number of triangles. Now for number of triangles, right, for a triangle I need 3 non-collinear points, and on a polygon all the vertex would be non-collinear, right? So number of triangles Tn will be given by what? NC3. Right? Now NC3 is how much? N into n minus 1 into n minus 2 by factorial 3, which is 6. So number of all possible triangles formed by joining the vertices of n-sided polygon would be given by this. Now I need to find out Tn plus 1. So I know Tn. Put n is equal to n plus 1. So if I put n is equal to n plus 1, I get n plus 1 C3. What is n plus 1 C3? Remember the formula, tail is 3. So I will write 3 natural numbers starting with n plus 1 in a decreasing order. So n plus 1, n minus 1 divided by 6. Now the question says Tn plus 1 minus Tn is given as 10. So now this is Tn plus 1. So n plus 1 into n minus 1 by 6 minus Tn. This is equal to how much? This is equal to 10. Cross multiply 6 and take n into n minus 1 common. So if I take n into n minus 1, I will be left with n plus 1 in the first bracket. Over here, I will be left with n minus 2. Okay? And 6 goes over here, this becomes 60. So if I simplify, this becomes n into n minus 1. This would be n will get cancelled and I'll have 3. So if I divide by 3, I get 20. Now I will give you a trick to find out the values of n directly. See, you can multiply, you can convert this into a quadratic and find out the value, but that will consume time. Inside the examination hall, we have a limited time. So we have to utilize every nanosecond over there. Now, it is a product of 2 natural numbers, right? N would be natural number, right? Because n is the number of sides. So product of 2 natural numbers which are consecutive. So write 20 as product of 2 natural numbers. Right, you got the answer. This is 4 into 5. So this is also product of 2 consecutive natural numbers. This is also product of 2 consecutive natural numbers. N and n minus 1. Which one would be larger? N. 4 and 5. Which would be larger? 5. So I know my answer is n is equal to 5, and correct option is option number 2. Right guys? So you can calculate the values of root when such kind of information is being given, but always make sure n needs to be a natural number. If n is a real number, then I can have too many real numbers which are multiplied together to get a product of 20. If it's a natural number, it has to be 4 and 5. If it is integer, it has to be 4 and 5, or minus 4 and minus 5 is also possible. But that is in the case of integer, not in the case of natural numbers. Now the next question. Number of ways in which an examiner can assign 30 marks to 8 questions, giving not less than 2 marks to any question. Now see, there are 8 questions. Try to understand this question because it's a very important concept, commonly also called as Bagger's theorem. Now there are 8 questions. Every question will be given some marks. Now all these 8 questions are distinct, right? They are not same. Question number 1, question number 2, question number 3, they all are distinct things. Now 30 marks. So whatever marks I give to question number 1, I have to give marks to question number 2 as well, to 3, such that the sum of all these marks would be 30. So can I say I have to distribute 30 marks in 8 problems, right? So let's say I call these questions as Q1, Q2 and so on till Q8. This will be equal to 30. So can I say I have to distribute the 30 identical things among these 8 distinct groups. Now, what is the condition? They should get less than 2 marks, giving not less than 2. Not less than 2. 2 is allowed. So I can say that Q1, Q2, Q8 needs to be larger than or equal to 2. Right? So now think in this particular way. You have 30 toffees, you have 8 students standing. You have to distribute these 30 toffees among these 8 students such that you should give minimum 2 toffees to any student. Now toffees are identical and I have a constraint, minimum 2. So why not I fulfill the constraint first? So now what I'll do is, I'll pick 2 toffees, right? Toffees are identical, so I can just pick 2 from it, give it to Q1. Done? Pick another 2, give it to Q2 and similarly give to Q8. So now there are 8 students and you have already distributed 16 toffees. So how many we are left with now? 14. Now these 14 identical things I have to distribute among these 8 people such that anyone can have any number of toffees. Now I can give this 40 into Q1, all of them to Q1 or all of them to Q2 or 7 to Q1 and 7 to Q8. I have no constraint. So whenever you have n identical things to be distributed among r distinct groups such that any number of things can be given to any group, right? If you find these 3 conditions, always remember your answer is n plus r minus 1 cr minus 1. One of the important concepts, you will find many problems based on this in JEE Mains and JEE Advanced in other competition exam as well. So what do you need to observe is, things needs to be identical. You should have identical things only. The groups in which you are distributing needs to be distinct. And this condition should be there such that any number of things can be given to any number of group or the people. If these 3 conditions are there, you can say a total number of distribution ways would be n plus r minus 1 cr minus 1. So now over here I have to distribute 14 identical things, 8 distinct groups. I can give any number of things to anyone. My answer would be 14 plus 8 minus 1 C8 minus 1, n plus r minus 1 CR minus 1. This would be how much? 21 C7. And if you see the option number 3 would be the correct answer. Right guys? So always remember this. Mark karke likh lo isko, very important from the exam point of view. Right? There is a high probability that you will find a question based on this particular concept. Now the next example came in 2011. Number of ways of distributing 10 identical balls in 4 distinct boxes such that no box is empty. Right? Once again, identical things I have to distribute into distinct groups. Condition is there, no box is empty. That means every box should have 1. So I will give 1 to every box. So there are how many boxes? I have 4 boxes. Identical balls. So put 1, 1, 1, 1 over here. So how many you are left with? Now you have 6 balls, right? So now 6 balls to be distributed among 4 people such that any box can have any number of balls now, right? Because I have fulfilled the condition. So my answer would be 6 plus 4 minus 1 C4 minus 1, that is 9C3. So hence statement number 1 is correct statement. What is statement number 2? Number of ways of choosing any 3 places from the 9 different places. A selection of 3 out of 9 is 9C3. Very well. This statement is also correct. But is this the approach or the explanation for this one? No, it's not the explanation, right? This is a selection, this is a distribution. So my answer would be statement 1 and statement 2 are correct, but statement 2 is not a correct explanation for the statement number 1. Right, guys? Because if you remember the derivation of the n plus r minus 1 cr minus 1, you would remember that we have done the arrangement, right? And the final value comes down as equal to n plus r minus 1 cr minus 1. It is not the selection of r minus 1 things out of n plus r minus 1 things. And 2 cannot be the explanation of the statement number 1. So that came in 2011. Now, the next question, I have a set S which has 12 elements. I have to partition, divide this into 3 sets of equal size. So 3 sets of equal size means each one of them will have 4, right? Now what is A union B union C is equal to S? So all the element that goes in A, B and C, if I take the union, it becomes S. So in short, all these 12 elements will either be in A or will be in B or will be in C, right? A intersection B intersection C, all these intersection are phi. That means any element which is there in A cannot be there in B. Any element which is there in B cannot be there in C. So any element goes either in A or B or C, but not in AB or BC or AC. Hence, that's why I have written every set will have 4, 4, 4. Otherwise, equal size can be 5, equal size can be 6, 6, 6. But I cannot have 6, 6, 6 because if I have 6, 6, 6, then some of the elements are being repeated. Hence, this condition will not hold true. So I have to divide 12 things into 2 groups of 4, 4, 4 each. Now think, how do we do this? There are 12 things and there are A, B, C, 3 students over there. So what I'll do, I'll select 4 and I'll give it to A. To select 4, 12C4 and give it to A. Now I am left with 8. I will select 4 from the 8 and I will give it to B. I am left with 4. Select 4 out of 4. There is obviously 4C4 and give it to C. So I can say my answer is 12C4 into 8C4 into 4C4. If you simplify this, right, many of the students would be wondering, sir, it's a distribution, right? We can use the formula. There is no need to remember the formulas. Why there is a need to remember the formula if I can calculate it, logically inside the examination? Now simplify this. So this gets out, this gets out. So my answer is factorial 12 upon factorial 4 whole cube. Right. So all the options look similar, right? Because there is no option over there. So it's okay. Your final answer would be factorial 12 upon factorial 4 whole cube would be the answer for this particular example. Now the next case, 8 identical balls in 3 distinct boxes such that none of the boxes empty. Similar example we have done right now, right? So we'll distribute, it's a Bagger's theorem, 8 identical balls, distribute 3 over here. Because I have a condition, none box should be empty. So how many we are left with? 5. And how many boxes we have? 3. So use n plus r minus 1 cr minus 1. So 5 plus 3 minus 1 c3 minus 1. Right? It's a 20-second problem. So my answer is 8 minus 1 is 7, 7c2. What is 7c2? Let us calculate this. So I have 21. If I look at the option number 2 is the correct answer. Right, so if you know the concept of Bagger's theorem, such kind of questions becomes a 20 seconds or 15-second problem inside the examination hall. And if you can answer a problem in 20 seconds, that saves almost 3.5 minutes and gives us 4 marks. So remember, these kind of concepts and logics are very important from the examination point of view. So with this, right, we come to an end of this wonderful session of PNC where we talked about the multiple samples of problem that have come in the previous year questions. We would be coming with some more examples and some more chapters in the coming days. For example, tomorrow I will be meeting with you all on the topic probability. So stay tuned, and you can also subscribe our YouTube channel. That is the first thing. Second, you can also subscribe the Telegram channel. Now, in this Telegram channel, right, we share the assignments, the notes, and the daily updates. Daily updates once again about the classes of physics, chemistry, maths, if there are any other workshops. So you will be updated, you will get the assignments, and you will also get the notes of the sessions, right? So here is the link for the Telegram group. You can go over there, right, Infinity Learn JEE, and you can subscribe there. You can also share it with your friends, right, who are also preparing for IIT JEE, so that they also get help from here. Thank you so much, Rishabh, right? Right, so there is this like, subscribe and share, right? These are the three things that we expect from each one of you. For rest everything, we are here to support and guide you. Thank you so much, guys. See you tomorrow at the same time. Bye bye and stay safe.